Come with me to a magical place where being labeled the pork queen is a compliment, where being nice is just a way of life, and where all leaders of the free world must pass through. Welcome to Iowa. Whether you're a current Iowan, an Iowa expat, or an Iowan at heart, this show is for you. This is the Iowa Podcast. Real Iowans, real talk, no drama. I'm Justin Brady, and if you haven't heard the news, there was a major nitrogen fertilizer spill in Red Oak, and we're still tracking the damage of this, but it's an area I don't know much about, and I'm sure it's an area most Iowans don't know much about. Therefore, we've invited Dr. Michelle Soupir on the show, professor at ISU, and you're, of course, Dr. Soupir, your specialty is in sustainable water systems, nonpoint pollution control, watershed management, water quality monitoring, and it's worth noting you have a PhD in biological systems engineering. So thank you so much for joining us. I really appreciate it.
Hi, Justin. Thanks for having me. It's great to be here today.
So obviously a concerning thing. We still don't know the full damage done. What we do know is 750, nearly, so it's, I think the actual total is 749,000 fish have died. And we're down into Missouri now. We've killed 40,000 fish in Missouri. And so that's what we're going to be talking about today, what the impact is for Iowans. Before we get started, everybody, really quick reminder, this show is everywhere. It's on your favorite app. You can listen on iowapodcast.com if you want. You can listen on Apple. You can even listen on Spotify or X, formerly known as Twitter. It's everywhere you'd want it to be, so make sure to subscribe. That actually makes me feel better about myself when you subscribe, so please do that. All right. Dr. Soupir, so the big thing is obviously it's killed a lot of wildlife, but what do we know, like the full scope of the damage just yet?
Yeah, I don't know a whole lot more about this than you do, but this is something that I think we'll continue to learn more and more as time passes.
Yeah.
I do know they're continuing to monitor the water quality to try and see that the ammonia levels are starting to decrease. But I'm sure it's going to be quite a while before we know the full extent of what's happened and the damage to the aquatic system and how long this will persist.
And so give us an overview of it's fertilizer, and it's liquid nitrogen fertilizer. And so can you give us an overview? It's not exactly like we're dumping arsenic, but essentially, it's not like we're dumping some poison into the supply, but obviously anything in greater amounts becomes a poison. So can you give us an idea? And for those that don't know, someone at it was in Red Oak, it's the NEW co-op, someone left a valve open for like 2 days, dumping 200, I had the number here somewhere, it was about around 249,000 gallons of liquid nitrogen fertilizer. So can you give us an idea of how this impacts wildlife and how this impacts basically our waterways and our land?
Yeah, I mean, and this is just a really extreme situation. I don't know if something like this has happened in the past, but really, really unfortunate. And so what we have is high levels of ammonia have entered into the stream, into the river system. And what that does is when you have high levels of ammonia in the water, the fish, it can build up in the fish tissue. And as that builds up with time, there's kind of an imbalance in the ions, and the fish aren't able to flush the fresh water, flush the ammonia out of the system. And that's essentially what can lead to death and why we had such an enormous number of fish. As you said, 749,000 fish died in this incident. And so, it's just really about the high concentration. Animals are pretty sensitive to ammonia and water. And it does depend upon the temperature and the pH of the water system, so that the form of ammonia can adjust based upon the environmental conditions. But with this much fertilizer being discharged into a stream system, we're going to have levels that are way, way higher than we would expect to see for aquatic life to be able to survive.
Yeah, obviously, I have a lot of questions on this, but the first one is I'm not a biologist and I'm not a chemist. And so when we read the news, we see liquid nitrogen fertilizer spill, and then you mention a lot of ammonia went into the river system. So are those the same thing? How do they impact each other? I'm sure to people like yourself, this sounds like an idiotic question, but I think most people probably don't know the difference, including myself, about liquid nitrogen fertilizer spill and ammonia. Is there just ammonia in the fertilizer? Can you explain that relationship?
Yeah. So ammonia is the plant available form. UAN is the kind of the acronym that we often see to describe that liquid fertilizer. I don't honestly know the details of exactly what was discharged, but I would assume it was UAN. And so there's that ammonia, which is actually the form of nitrogen. So the nitrogen cycle can change throughout the environment into different forms. And so ammonia is kind of the plant available fertilizer that we tend to apply to cropland. And so in addition to that, it has that negative impact on the aquatic environment. And so the combination of the two was just when we say liquid nitrogen fertilizer, essentially we're referring to this plant available form of nitrogen.
So yeah, what is obviously, you mentioned it's not good for wildlife. It's obviously, I'm going to assume, not good for drinking either. And I think that they have the DNR and local water treatment facilities have alerted people to monitor their well water quality. What is the long-term impact in the water supply? Should people in that area be not drinking tap water or well water? Should they be, using bottles because the long-term impact's not great? What's the recommendation for people that are downstream of this disaster?
Yeah, I think it depends on where their water supply is coming from. If they're in a private well that may not be, tested on a regular basis, and they're located close to the river system, it depends on kind of what is the hydrology, how is the water that's in the river interact with the groundwater that's nearby, and thinking through if there's a private well that's located somewhere close to that river system, they definitely would want to get their water checked to see what the nitrogen levels are. If the water is coming from a facility that treats the water, there's typically really consistent testing to determine if the water is safe for consumption. So I would expect that if the water is coming from a water treatment plant, that they would be able to ensure that the water is going to be safe before it's distributed out to homeowners. When we think about drinking water, so again, that nitrogen cycle and how nitrogen moves from different forms, of course, we wouldn't want to consume ammonia, so it's toxic to fish. It's also not recommended that you would drink water with higher levels of ammonia, but we do have water quality standards for nitrate. And so nitrate is what we often hear about in the Des Moines metro area. Currently the water quality standard is 10 milligrams per liter. And so oftentimes in the spring in the city of Des Moines, we can have a hard time meeting that water quality standard just due to, natural runoff that's occurring from agricultural cropland. And so with a situation like this and that huge amount of fertilizer that was essentially discharged directly into the stream system, that's a really extreme situation. And I guess I'm not aware exactly of what the communication plan has been or what kind of outreach has occurred, but especially for folks on private wells that may have been located closer to this area, I would definitely recommend getting your water tested, and maybe even reaching out to your local water treatment facility to see if there have been concerns or what the source of water is in that area.
Yeah, it's good advice. Do treatment plants, like, do they change their processes when something like this happens? Because that's one thing that's always been crazy to me is how treatment plants work. It's like a very fine science, and they don't just have massive filters everywhere doing this stuff. They have to constantly take measurements, and they have chemicals that get the bad stuff out, for lack of a better term. So, do they have to immediately change their processes when they hear news of this, or is it just business as usual?
Well, yeah, and it's actually a pretty expensive and specific equipment that has to be used to remove nitrate. So Des Moines Water Works has installed a nitrate removal facility that can be turned on and off when nitrate levels in the Des Moines River and Raccoon River exceed that the safe level of 10 milligrams per liter. And so for the case of Des Moines, they actually will turn on the treatment system as needed. It costs extra money to operate it, so they kind of try to minimize it unless they would absolutely have to. So in this part of the state where the spill occurred, most of those water treatment plants aren't going to have that nitrate removal facility. In the case where they likely won't be able to just turn something on that would allow them to remove high levels of nitrate. So to me, that means that they're probably they may have to look for a different source of water, or they may need to, dilute. If they were to pull water from a stream system, they may need to dilute in that case in order to achieve the EPA water quality standards. So there's a couple of different options, but they're, in areas that are smaller and don't have the big water processing technologies that we have in Des Moines, that would not be an option.
So this is actually a legit concern then for people in this area, even if they're getting tap water from their local treatment plant. Obviously, I don't think you have any knowledge. If you do, please share. But this, even if it's coming from a tap water that's gone through a treatment plant, and you're downstream of this could be impacting your tap water.
Yeah, well, they do test. So that is a pretty standard protocol, frequent testing of the water quality to make sure that it's safe for public consumption. So again, I don't have a lot of information on this specific area or what the water treatment process is. I haven't seen in any of the press releases that there have been concerns for consumption of drinking water. So from that perspective, I don't know that there's been any kind of, alerts issued to the public. Again, I don't have a lot of specific information about this area, but they do require frequent testing at water treatment facilities. And so for the most part, you can trust that the EPA criteria are being met if the water is being distributed through the treatment facility.
It's good to know. You mentioned something interesting I want to go back to. You mentioned that it becomes harder to keep the levels of nitrates and the safer levels of water in the water supply during the summer due to and is this primarily due to all the all the runoff and the additional nutrients getting into the water supply, any like manure getting into the water supply? Is this why it's more difficult to manage our drinking and our tap water in the summer?
Yeah, it often, it depends on the weather conditions. So, our heavy rainfall period across most of Iowa is in the spring. That's also when actively in the field, applying nitrogen fertilizer, manure application can take place in the spring. It can also take place in the fall, depending upon the amount of storage the facility has and just kind of when the manure applicators are available. But then we tend to get, the majority of our rainfall in the spring period, and that is what moves the pollutants downstream. So fertilizer can move off-site and surface runoff. It can also infiltrate through the farm fields and be intercepted by tile drainage, and then move rather quickly into to streams and rivers. So tile drainage is very important. It's if you're not familiar, it's like if you think of a stormwater system in an urban area, those pipes that are placed underneath the roads to make sure water moves off of roads quickly so we don't have flooding in towns. It's a similar concept in agricultural areas. We're trying to lower the water table so that we don't drown out the crops, mostly corn and soybeans. So we want to be able to keep that root zone aerated and move that water down below the root zone. And so that network of pipes has been installed across kind of the north central part of the state. One challenge with that is that nitrate is negatively charged, so it can move through the soil profile pretty easily. Soil particles are negatively charged, the nitrate's negatively charged, and so as it moves through the soil profile, then it enters into those networks of pipes, the tile drainage, and then can move pretty quickly into surface water systems. And so that's where the risk occurs, because in that early spring period, the plants aren't fully mature, so they're not using as much water. Fertilizer has typically just been applied prior to planting, and so there's more fertilizer available to move through the soil profile.
Now, is this a matter of just like nutrients that are naturally occurring, but when they become, but in certain rainfalls, certain days, those nutrients just become higher in concentration, which is why this poses a problem? And maybe this is a dumb question, right? Because I'm obviously a lifelong Iowan, but that doesn't mean I know everything about agriculture and farming. So
Yeah.
is this a matter of like just higher levels of naturally occurring nutrients that are getting into the water supply because of rain and in certain seasons? Or is this a matter of like toxins that shouldn't be sprayed on the fields at all? Like, I don't understand what, like, in my dumb mind, not understanding agriculture, I naturally think, why are we allowed to spray this stuff on fields if it's like getting toxic, if it's making the water toxic? So what's the actual challenge here for
No,
someone who doesn't
it's not a
understand the
dumb
issue like
question at
myself?
all. First of all, and it's very complicated, right? So we have some of the best agricultural soils in the world. I went to undergrad at Kansas State University, and I still remember taking a intro to soils class, and the professor was from Iowa, had gone to Iowa State, and was just, the best soils in the planet for agriculture are located in near Ames, Iowa. So it was kind of neat to hear that, and then now live here and understand how complicated it is. So much of the, at least the kind of north central part of the state is glacial till, and so it's very, very nutrient rich, high levels of organic nitrogen. And it kind of comes back to that nitrogen cycle that I referred to a little bit earlier, where the nitrogen can change different forms. The organic form of nitrogen is actually pretty stable in the environment, but it's constantly changing and becoming mobile. So the organic forms are broken down, and then they become mobile so that they are available to the plants. And so then the plants can take up those nutrients, and of course are needed for crop growth. So really the question comes down to we supplement with nitrogen fertilizer because we don't want to deplete our naturally organic soils of the nitrogen that they already have. And there is some depletion that's taking place, but there is not enough nitrogen in the soil to support the kind of cropping system that we have. So, so the nitrogen is added to support the plant health, but we need to find ways to be able to supply that nitrogen to the plants at the right time, at the right place, so that it's available for plant growth, but not in that mobile form, just sitting there and waiting, for the next rain event that will then carry it downstream to our river system where we don't need additional nitrogen. So it is present naturally, but to meet the crop demands of our current agricultural system, extra is added. So that's where we often hear nitrogen and phosphorus, and we have excess of both in our river and lake systems pretty much throughout the state. We have high levels. There are also, of course, other herbicides, pesticides, insecticides that are applied to support crop growth, to deal with different types of pests, and then those are definitely chemicals that are not, naturally occurring or naturally existing in our system.
Right, and that's a whole nother issue,
Yeah,
obviously.
that's different from this particular spill, but
Yeah, and that's
um,
maybe an issue that I'd like to cover on a future episode of the Iowa podcast for those wondering. I would like to understand. But for our purposes today, for water and this spill, it sounds like what we're dealing with in Iowa agricultural land is less, just again, this issue specifically is less about like spraying toxins everywhere that are getting into the water supply and more about balancing naturally occurring elements like phosphorus, like nitrates, stuff like that, or like nitrogen.
yeah, absolutely. And this huge tank of nitrogen was expected to be applied to cropland, probably really close to the time when planting takes place, so that it would have been available for crops to use. And then, yes, of course, some fraction of it would have made its way into our waterways, but nothing like what happened with a valve being left
Right,
open for a
right.
couple of days and the entire tank just discharging into a local drainage ditch. So yeah, you have to think about that this was not intended to be discharged by in any means in that way, right?
Yeah.
That was truly an accident, and there's a lot of work, a lot of research, there's a lot of effort because nitrogen's very expensive. It's not something that a farmer would just want to apply excess, or you don't want to limit your crop yield by not having sufficient nutrients for crop growth, but you also wouldn't want to waste money applying fertilizer that you don't need. So how can we improve that, getting the fertilizer to the plants where it's needed, when they need it, but not actually applying a surplus. So there's a balance, and there's a lot of work with digital ag, new technologies that are being developed to try and help reduce the amount of fertilizer that we use, but still not lead to a decrease in crop yields.
Yeah, I mean, so what is there in some of the articles I was reading, it mentions how the DNR is working with the NEW co-op now to do a cleanup process and do a cleanup in that area. I understand cleanup processes when I spill stuff on my kitchen floor because it's like a hard surface and the other stuff is not like mixed, so I can just vacuum it or
Yeah.
or even if I drop like a glass vase outside in my yard, I can go if I really want to get granular, I can at least go with tweezers and pick up each little shard out of my yard, right? But
Right,
what is
right.
the process for cleaning up a chemical like this? In this case, liquid nitrogen that has gotten into soil, all over the soil. It has gotten into the water supply. How like, can you walk us through how it's even possible to do a cleanup process like this?
Really, that's a great question. I don't even know what it is, to be honest. Yeah, I've seen things where they'll naturally let predators or wildlife clean up the dead fish. In this case, because there were so many, they may be going through and trying to physically remove the dead fish. But yeah, I'm sorry, I don't know what the process is. I actually was wondering the same thing when I was reading some of the articles.
Yeah, I mean, it's maybe that's also a future future episode as
Yeah, there
well.
you go.
But I'm like, how does someone even begin to do this? I still don't really understand like oil cleanup when they have oil spills in like oceans. I still don't even understand how that works, other than the fact that oil and water don't mix. So maybe that helps them.
Right, maybe
Um,
it's a little easier to try and like sop it up
yeah.
with
So
something like a oil fill. Yeah.
in the
Um,
case of like a gas station, right? Like obviously to prevent gas spills, because gas stations, and there are laws around this, but the possibility of someone leaving the gas thing, leaving their gas valve open and just spilling gas all over the place is pretty likely because people are
mhm.
using these things all the time, and it's just the general public and people when they take the fuel out of their car. Man, I'm butchering how this is like one of the most basic things. We fill up a tank of gas, and I cannot sufficiently describe this to listeners for some reason, but I think everyone knows what I'm trying to say. We have measures in place, and those systems, the drainage system around your gas station, doesn't go directly directly into the sewer, right? Because they
Yeah.
anticipate spills are going to happen, oil's going to leak out. When you fill up your gas, you're going to spill some on the concrete. They anticipate that stuff. So do they not anticipate this for like co-op areas with 250,000 gallons of liquid nitrogen? Is it just there's no protective measures whatsoever?
Well, it sounds like that was the case here. We run a research lab, and so if we are using a chemical, we have to have some secondary containment, right? So if we've got a chemical, we may need to sit it into a large tub or a container if it's hazardous that we could, that would catch anything that we might spill so that it doesn't run into the floor drain, which then, goes out the building.
Right. Yeah.
And so, yeah, there's definitely protocols in place for those types of situations. I don't know the details as far as this particular facility, if there were other containments in place. I mean, there was a valve, right? So that was left open. Um, and that to me there and then it seemed like it just probably pretty much went directly into a drainage ditch, a
Yeah,
ditch
that's what it
along the
sounds like.
field, which then moved into the larger stream system.
So, yeah, I mean, I guess we have yet to know for sure if there was some capture method in place. It sounds like there wasn't, just based on the news I'm reading. I'm not an expert in this area, obviously,
Yeah.
but so like I want to talk about preventative measures. Should there be? I don't know why I'd pronounce that like someone from Great Britain, but it happened. And we're
Yeah,
just going to go with it.
sounded
Um,
good.
so, how do we prevent stuff like this in the future? Do we put more preventative measures? Do you have recommendations from a research setting of what we should be doing to protect the waterways from future spills like this and keep things more pure?
Yeah, I think there's probably some pretty common sense things that we could uh, consider, and no, not an area of expertise for me as far as kind of the on-farm management, but it does seem that these things could be located. Further away from streams so that if a spill did take place, like you mentioned, the gas station type of a thing where there's kind of collection units on site. You'll see drains sometimes near the gas pump so that it could collect and go into kind of a small underground type of storage tank. It's probably not feasible for these on to farm type of tanks, but it would be something to consider. I work more in kind of the space with manure application, and those systems are designed as zero discharge. So in order to get the manure out, typically the pit is located underneath the barn. So you have to put a pump in and be able to pump it out. There could be,
Oh, interesting.
yeah, so it's not something where you would just typically open a valve and a large manure spill could take place. You actually have to go out and physically pump the manure out of the system into your tanks, and then you go out and apply the manure to the field or pump it to the field through some kind of a drag line. You could, I don't know, it's a very unfortunate situation, and there's always the the economic piece as far as what can we do to protect situations such as this from taking place versus over designing every single thing that we put. You can't we think about risk, right? There's risk in a lot of different spaces, and how much risk is acceptable? What are the chances that something like this would happen? And what can we do to try and prevent something like this from happening again?
Right. Just last question before I let you. Well, maybe another. We can sneak another one in here if we're really lucky. But last question is, what is the like long-term impact if we don't get stuff like this under control and this continues to be a problem? What is the long-term impact? Is it just a water quality thing? Is it more wildlife dying? Is it increasingly getting more difficult to farm our land? What's the long-term impact of not protecting the waterways?
Yeah, I mean, we need to think about this kind of in the bigger scale, and someone said to me just last week, Iowa is really a water state. And you think about, we're not a state that doesn't have great water resources. We have a lot of precipitation, we have a lot of water, and we have a lot of opportunities to engage with water. And there are a lot of opportunities to bring, economic growth and development around our water resources. We think of Minnesota and all of the lakes and the fishing and the opportunities to get outside and enjoy nature. And I think we have those opportunities in Iowa too. Thinking of some of the projects, the icon, the water trails that are being developed in Des Moines, the biking, potentially rafting, all these different resources that we have. The water is here, but if it's not clean enough to get into it or safe for people, we won't be able to really build out and
Yeah, exactly.
develop this as a resource for people across the state. We need to find ways to attract more people to the state for workforce development. And, that's something that's really attractive to young people, the ability to get outside and enjoy nature. And
Good
so I
point.
just think that, recognizing what a great resource we have in this state, and then there's all the details of how can we prevent this from happening again, or how do we manage all really, really complicated questions about, our ag economy and how we can support agriculture and support industry, but also balance that with protecting our water resources. And so, when we think about the future of our state and our economy, there's great opportunity to build upon this water, this really abundant water supply that we have. And there's so many benefits to that. But then, if things like this continue to happen, we're not really going to capitalize on this resource.
Yeah, absolutely. Dr. Michelle Soupir, professor at ISU, Iowa State University, of course, in Ames. And of course, you focus on sustainable water systems, nonpoint pollution control, watershed management. You're basically the water expert. Thank you so much for coming on the Iowa podcast. Really quick before I let you go, how can people learn more about your work and what you're doing up there at ISU?
Well, I do have a website. So if you want to just Google Michelle Soupir, Soupir. I'm also on Twitter. It's ISU Water Chicks. I share that with another
Nice.
Water quality researcher, Dr. Amy Kalita.
Was the ISU Water Chicks?
Yep, that's correct.
That's great. We'll make sure to tag that when we share it on X, formerly known as Twitter, or whatever we're calling it these days.
Yeah.
Dr. Soupir, thank you so much for joining me and everyone listening on the Iowa podcast.
Thanks so much.
And to my fellow Iowans, Iowa expats, and Iowans at heart, thanks for listening and subscribing to the Iowa podcast.